Today we're going to be looking at and inequalities. These are still compound, meaning we have more than one, but it's going to be slightly different than or. So we've seen this sign before. Now we're going to look at this question. How fast can we legally be driving? Well, it says my maximum is 80 and my minimum is 40. That means to be legal, I need to be driving somewhere between 40 and between 80 in that part right there. That's the kind of graph we're going to be looking at. And how would we write that as an equality? There's a couple ways. We could say that our speed has to be between 40 and 80. Our speed has to be less than or equal to 80, and our speed has to be greater than or equal to 40. This is one way to write a compound inequality. That's an and. Another way to write it is simply this. Our speed is greater than or equal to 40, and our speed is less than or equal to 80. These two things mean the same. Okay, so you need to get used to both writing. Let's look at another one. To get into Washington University, you need to get greater than a 29 on your ACT, but the highest score is just a 36. So, we're going to make a number line here. We're going to go 27, 28, 29, 30, 32, 33, 35, 36. It's really not a 37, but good. We know we need to be bigger than a 29. So we don't want to include 29, so we put a circle around the 29. But we can score a 36, so we're going to fill it in, and then we connect it. So again, the way we would write this is we would say our ACT score, call it X, has to be between 29 and 36. But we know the score has to be less than or equal to 36, but it has to be just bigger than, it cannot be equal to 29. That is one way to write that graph. Another way to write that graph is X is bigger than 29, and, you gotta use the word and, X is less than or equal to 36. So what's the difference between an and an or? We're going to look at that right here. We've got the exact same problem, only this compound inequality has an or and this one has an and. So I'm going to put, I've got between 2 and 4. So I'm going to go 0, 1, 2, 3, 4, 5, 6. And this says X is less than 4. So I'm going to do that above the graph, not on the graph, but above it. So I'm going to do an open circle at 4 and I'm going to go to the left. This one says X is greater than or equal to 2. So it's a filled in circle at 2, and it's greater than, so it goes to the right. So what's our solution? Remember, we said or means any solution. Okay? Or means any solution that is red or blue. Doesn't have to be red or blue, but basically if it's in one set, then it is a solution to the or. It doesn't have to be in both, it just has to be in one of them. So what numbers are solutions to the blue? Well, all these are solutions to the blue. But which solutions are solutions to the red? Well, all of these are solutions to the red. So basically, what is a solution to this one is the whole number line. The whole number line is red or blue. So then we say all numbers are solutions. So again, for an or, we were just looking, where is it red, where is it blue? Doesn't matter if it's both, doesn't matter if it's one of them, as long as it's red or blue, then it's a solution. And now let's look at this one where it's an and. Still going to graph the blue one. 0, 1, 2, 3, 4, 5, 6. The blue one is an open circle at 4 to the left. The red one is a closed circle to the right. What and means is that and means must be a solution to both. To both sets. So that means it has to be red and blue. It can't just be one or the other, it has to be both at the same time. So are these numbers red and blue? No, they're just blue. These numbers over here are just red. The ones that are red and blue are the ones where they overlap, kind of right here in between. So that's a solid circle at 2, all the way until I get to an empty circle at 4. And then so here's my answer. My answer for this, as we talked about, can be written as my x is in between 2 and 4, and less than 4, but greater than or equal to 2. So you can see the difference between an and an or. Or means as long as it's in one set, it's a solution. It doesn't have to be in both. And says it has to be in both to be a solution. That's the difference between the two words. These are not in your notes, but these are just some examples for us to kind of practice. So I want you to kind of follow along. And what I've got is, I've got a sentence like this, and I've got choices to see which one means the same thing. Well, if we go back and look, this is a compound inequality. It's all joined together, right? One big thing. Well, if I go back and look at some of our examples, like this guy, that was an and. If I go back over here, here's 2 inequalities in 1. That was an and. Whenever you see an inequality written like this, that means and. Okay? So I can kind of break it up into 2 things. I can break it up into the blue piece. I stop at the second inequality. And I can look at the red piece. So let's write out the blue one. I'm going to write the y value first. The y is bigger than -3. And because they were joined together, it's an and. And the red, y is less than 5. So where's our choice? Right there. Okay. Notice that I know I kind of flipped the sign here, but that's because I flipped the order. What I did when I looked at the blue, I just said, if this was an alligator, what's it eating? It's eating the y, so I want to make sure it's still eating the y. Okay. Let's look at another one. Again, not in your notes, but we just want to think about it. This says x is greater than -5 and x is less than 1. Well, you could graph that if you'd like. That's one method, is to graph. Another method is just to kind of say, okay, well, they both have x, right? So we're going to put x in the middle. And then we're going to say this x, we know, is less than or equal to 1. That's what this says. But we also know that it's greater than -5. So we're going to write greater than, x is greater than -5. I look for this one, and it appears to be right here. And again, I know I went from a greater than sign here to a less than sign here, but that's because I switched the order. The x is bigger than -5. My x is still bigger than the -5 because it's eating the x. If you wanted to, you could have graphed the 2 equations. -5, -4, -3, -2, -1, 0, 1, 2. And you could have done one of them. You could have said x is greater than -5. And then you could have said x is less than or equal to 1. And said where they overlap is between -5. This should be an empty circle. Between -5 and 1. So then you wrote x is between -5 and 1. Okay, so 2 ways to do it. You can just jump straight from here to the writing, or you can graph it, look where they overlap, and then write. Now we're going to get to the solving part. solving the inequality and graphing. Okay? To solve it, it's it's two different inequalities. Just focus on this one first. Okay, and I'll do it blue. It says negative 8x is greater than greater than 24. The way I get rid of a negative 8 is by dividing by negative 8. But because I divided by a negative, what do I have to do? Flip the inequality. Okay, so I got that guy. Come over here, do it red. How do I get rid of dividing by 5? And multiply both sides by 5? Okay, kind of running out of room here. Multiply both sides by 5. So these 5's cancel, and I'm left with x is greater than negative 10. I didn't have to switch the sign because I didn't multiply by a negative number. So before I even do anything, now I'm going to come down and I'm going to graph it. I'm not going to write my answer until after I've graphed it. Right? So I'm going to go negative 11, negative 10. And we're going to do it above the graph. So x is less than negative 3. So it's an open circle at negative 3. And goes to the left. This is x is greater than negative 10. So here's negative 10. And because it's greater than, I'm going to go to the right. And now I have to ask myself, I have to look at the inequality. Is the compound inequality an and or an or? Because it's an and, what do we look for? We look for where the two sets overlap. Well, they overlap between here and here, and everywhere in between. So it means I'm going to put my solutions are from here all the way to negative 3. Now how do I write this answer? Right? Well, I can write it a couple different ways. The way I like to write it is this. I say my x has to be between negative 10 and negative 3. I'm definitely less than negative 3, but the x is bigger than negative 10. This is my final answer, right here. When I grade your test, when you do any kind of assessment, this is what I'm looking for. I'm looking for this part and this part. This is the work that helped us get to here. Okay? You're looking for the number line, the shaded part of the number line, and then your final answer. Another one. This guy's a little bit different. He's kind of two inequalities in one. You can almost picture invisible lines kind of here and here down the inequalities. And what we're going to do is we're going to say, so you can see three parts. We got the left, the middle, and the right. The left and the middle, the whole middle, is one inequality. Not just the x, but the whole middle, which is the whole middle is x plus 3. So I'm going to write that inequality. Negative 6 is less than x plus 3. Oops, not 13. 3. Then I'm going to do the middle section in the right. So now I have x plus 3 is less than or equal to negative 4. And remember that whenever it's joined together like this, this automatically means it's an and. Whenever you see two inequalities in one thing, it's automatically an and. So now I just got to solve each one of these. Minus 3, negative 9, less than x. If you remember, we talked about this in class, I personally like to have the x in front. So that means that the x is eating the x here, so I still have to eat the x there. We'll come over here and subtract 3, less than or equal to negative 7. My x is first, so I'm good. So now I'm going to make my number line. Right? So we're from negative 10, negative 9, negative 8, 7, 6, 5. It's probably good enough for now. And again, I'm going to show my work above it, but I'm not actually going to count it as my answer. I'm greater than negative 9, or I am less than or equal to negative 7. And then I look at my inequality, it's an and. And tells me which part do I want. I want the overlap. So I want from here to here, and everywhere in between. So then I want to write my answer based on that green answer. My x's are between negative 9 and negative 7, less than or equal to negative 7, but bigger than 9, negative 9. And again, that's my answer right here. This is what you're going to be graded on. You got to show all your work, okay? But that would be the final answer. One more. Okay, this one's already separated for us. Solve the inequality and then graph the solution. So we're going to do this one. We're going to add 9 to both sides. Negative 9x is less than or equal to 18. Divide by negative 9. Because I divided by a negative, what do I have to do? Flip the sign. When I come over here, I'm going to subtract 4 from both sides. I get 5x, it's less than negative 25. Divide by 5. Do I need to switch the sign here? Yes or no? What do you think? No, I don't. I know this is a negative number here, but I'm not dividing both sides by a negative number. I'm dividing by a positive 5. The answer just happens to be negative. So let's take a look at this one. I'm going to make my number line go from negative 7, negative 6, 5, 4, negative 3, negative 2, negative 1, 0. That's good enough. I'm going to do the blue part above the graph. So I am greater than or equal to negative 2, less than or equal to, or just less than negative 5. And I got to go back and look at my original problem. It was an and. What does and mean? Hopefully you can catch on to this. And means, where do the two sets overlap? Do these overlap at all? No, they don't. So therefore, if there is no overlap, then there is no solution. The answer to this is no solution. I'm not going to shade anything on the number line because the number line represents for an and where the two sets overlap. These don't overlap, so the answer is no solution. Okay? I think I have 2 U-tries for you to do. So I'm going to give you the first one. I want you to pause the video, work it out, and then check your work. Alright, hopefully your graph goes from negative 3 to 10. I did have to count by 2s here, that's okay. You can do that if you need to. If you need to count by 3s, that's fine. 10 would just be between the middle of 9 and 11. And then I wrote my final answer in a nice pretty format. Okay? If you got this exact answer, go ahead and fast forward to the next U-try. If you didn't get it, then you might want to hang on and listen to the explanation. The first thing I want to tell you, for those of you who did not get it, again, if you did get it, skip ahead. If you did not get this right, there are 3 sections. There's this section, there's the left, there's the right, and then everything else is in the middle. Okay? You don't separate the middle. So I have the left, the middle, and the right. Okay? This is less than all of this. That's my first inequality. Then I write the middle is less than this. That's my second inequality. I solved them. Each time I had to divide by negative 7, so I had to flip the sign. But at the very end of this one, I want to point out right here, I didn't like my variable on the right, so I moved it to the left. It said A has to be smaller than 10. And that's why I went to the left here when I graphed to the smaller numbers. That was probably the main thing. And then once I got down to red and blue graphs, I said, okay, I need an and, because remember, if it's written together, that means and so I was looking for where did the graphs overlap. And this was my final graph answer, and then this was my final answer at the end. Okay. Let's go to the second you try. Here's the next you try. Go ahead and pause the video, do this one, check to see how you did when you're done. Alright, skip straight down to the answer. Your answer should just be a single array going from -1 on to bigger numbers, which means our answer would be all x's that are bigger than or equal to -1. This matches this graph right here. If you got that right, great. Go ahead and fast forward to the summary slide. If you didn't get it right, hold on and I'll do some explaining. Over here, I subtracted 5 on both sides. Don't add 5. 5 minus 5 is 0. That's what causes those to cancel. You have to bring down a negative x. And because of a negative x, I divide by a -1 right there. Because I divided by a negative, I had to flip the sign. Over here, subtracted 3 divided by 2, so I get x is greater than -5. And I just graphed each one. And then once I graphed the red and the blue, I said, okay, I've got an and. And means where do they overlap? Well, they overlap right there. So that is where I drew my final answer. And then I just looked, oh, the numbers that I've highlighted, the numbers I've shaded are all numbers bigger than or equal to -1. So that was my inequality. This is the final answer. Alright, here's your summary video. A couple questions I want you to answer. You can write them down in a journal. You can write them down somewhere on this sheet of paper. You can write them down anywhere you want. But do think about these because we're going to talk about them in class. What does or mean? What does and mean? And then describe the steps that you would use to solve an and inequality. So if you had to teach somebody how to do this, what steps would you give them? And then tomorrow in class, we will talk about those.